All right, we are recording. Do you have questions about it? It's okay. If you have questions, I've got a few slides. It's not coming in your quiz, right? It is just a master's student had this question. So I just would like to tell you, both are okay, right? Now, students have confusion. What is alpha? What is this? Some students in my master's class said, aren't these same thing? No. This is your threshold. Threshold means it's your objective, your aim. For example, some of you want to get, in a statistics class, you want to get 90, right? That's your score, 100. That's your alpha. But when I do quizzes with you, you get 85, right? That's your P, right? So you begin your class believing I'm going to receive 90% in this class, right? But in real, you get only 85. So this is the difference between alpha and P. So alpha is the probability of, you decide, I'm going to make 5% mistake. But P value is your real result, Z statistics, what you got. The P value will say, with this result, with this Z statistics, the probability of you making mistake is this much. So you begin with 0.01 probability. You said, oh, my results will be 99% correct, means 0.01. When you got your Z statistics, you found out your results are actually more accurate than 0.01. So your p-value is less than 0.01. Means your results are very good. Your results have very little error. So you're going to say p is less than 0.01. Yeah? Where is this p coming from? You use your Z statistics and you go to the Z table. Do you remember Z table? Mm-hmm. And you would look at the value in Z table. So, I mean, it's again not part of your T. We are supposed to study T statistics, but because my master student raised this question, I thought maybe some of you would like to know as well. It's not in your slides that I have uploaded, but just for your clear information. So here, Z statistics, if it is more than the critical region, you can also say P is less than 0.05, and this is the table. Remember, I've given you the table. You can find this table anywhere in any research method book at the back. You can also find this table on web. You just Google Z. So P value for 0.01 means top 1%, right? 0.01 means top 1%. Remember the Z score, we did that. So 95 is 0.5%. If you say if you say top 5%, it's 1.64. Top 5%, where is that? 5%. You have to see the 1. It's not showing here. Top 5%, right? Or in the tail. So top 5% has the value of 1.64. Similarly, if you say top 1%, which is not showing here, 3 only, here, 1%, so right here. Top 1% would be, let's say, this one. So your Z statistics would be 2.29. Your p-value will be 2.29. Don't want to confuse you, just want to tell you. If you're interested, I can share these slides with you later. All right. Today, our objective is to talk about t-test. So as you said that you've not heard of t-test, which as I said, I'm happy that you've not heard of t-test. Okay. We are going to take 3 examples just to begin with to understand what is t-test. I am not sharing with you statistics. I'm just sharing with you real examples. There are 3 kinds of t-tests that we will be looking at. I am not following the slides one by one. This noise is so annoying. Okay. Okay. I hope I don't get this anymore. Okay. Looks like a big definition. Early in the morning, it's cold morning. What is she showing us? T-test examines the differences in the mean. Take your time and digest it slowly. T-test examines the difference in the means of course, parametric. Hold on, don't worry about that. Dependent variable across 2 groups or conditions, that is independent variable. Just think that. Remember, independent variable and dependent variable? Yeah? Any example of independent and dependent variable? Can I hear any example? Give me an example of IV and DV.
The time I spent in psychological statistics class. This is
Perfect.
DV is the score I get in the quiz.
Oh, excellent. IV and DV, we all know that, right? So time is an independent variable and DV is a score. T-test will examine the differences between DV. This is the DV. But of what? Across 2 groups. You get that? 2 groups. Now, we need 2 groups. Let's say this is group 1, this is group 2, IV. See? Across 2 groups or conditions, which is the independent variable. So let's say group A studies only 10 hours, while group B studies 20 hours. Okay, everybody with me? Yeah. Now, DV. My objective is to check if the DV of these 2 is any different. Yeah? So I'm going to use the statistics, which is called t-test. T-statistics. Now, if you look at this picture, it's pretty easy and clear to understand, but this looks a little bit complicated. But now try and see. A t-test examines the differences in the mean score of dependent variable. Parametric, we will talk about that, but hold on. It looks at the mean differences, the mean score, right? Mean 1 and mean 2. It looks at the differences between the mean scores of dependent variables. Group A, Group B, right? How have we made these 2 groups? We have made these groups on the basis of the independent variable. Why are these 2 groups different? They are different on the basis of the independent variable. Clear? This is a complicated definition. I would like to find out if boys in this class are better than girls. Or if I'd like to find out if boys are happier than girls in my class. How many groups do I have? 2 groups, boys and girls. So my independent variable is gender. I divided 2 groups. Now what's my dependent variable? Happiness. I want to compare the mean happiness of boys and the mean happiness of girls. As simple as that. Right? Perfect. Great. Now, we are going to learn 3 types of three types of t-tests. All your life, when you go and do your master's, you should not tell your professor, I do not know what t-test is. You should tell your professor, yeah, I know what t-test is, and I also know there are three types of t-tests. The first one, which we are going to focus today, is called a single sample t-test. Honestly, in my life until today, I have never used single sample t-test. But it's a good idea for you to know what it is. The most common, in fact, for my PhD, I used dependent and independent t-tests. Right? Now, how are these tests different? It's very important for you to understand. So, for next 3 classes, we are going to be talking about only t-tests today, Thursday, and next Tuesday. So you should understand, you should remember, right? Now, when we talk about single sample t-test, you can check, you can see the example here. If I'd like to compare Psych 3200 scores with mean performance of other classes at WKU, this is called single sample. Now, remember in Z-score, I was always talking about your score, your cousin's score, and your score, one person's score. When you say single sample t-test, you don't mean one person, you mean a group. Yes? So, I am very bad at drawing, but if I were to draw single sample t-test, I'm going to draw like this. I want to go there, but I can't. Single sample t-test is my PSY3200 class, all of you, right? I'm going to compare all of you with the entire population of WKU. Is that okay? Yeah? This is single sample t-test. We will talk about what knowledge will I have when I want to compare the mean of this with the mean of this. Does anyone have any confusion? Any confusion? Is it clear? Okay. Dependent or paired t-test. Now, dependent and paired t-test is, again, comparisons of two mean, but not of two groups, of the same group. Yeah, yes? Just remember the word pair is very good, right? Or dependent means the score of both the groups is dependent because they are the same people, right? Now, in this case, I will again take PSY320, your class, PSY3200, 6 weeks, I'm going to teach you using videos. This is called time 1. And another 6 weeks, I'm going to teach you using mobile phones. Right? You are my same class, 3200. I'm going to compare the differences between mean 1 and mean 2 of time 1 and time 2. Is it clear? Yes, good picture. This kind of t-test we are going to call paired t-test, or we are going to call dependent t-test. Okay. Independent t-test looks a little bit like this, but here you have a very small single sample, right? The dependent t-test is simple. You're going to take 2 equal groups, but not the same groups, different groups. Okay? Now I am teaching WO2, PSY3200, and I'm also teaching WO3, PSY3200. Now I've got 25 students here, and I've got 25 students here, right? Again, I might want to teach them using videos, and I will teach them using mobile phones. My hypothesis is there will be a significant difference between both the groups' exam performance. But you do not know if students learning from mobile will perform better or students learning with videos will perform better. We don't know yet. I will just hypothesize there will be a significant difference, or I can also give null hypothesis. So in this case, I've got group 1 and I've got group 2. Okay? So it's very similar to there, mean 1 and mean 2. The only difference is this one is a single sample, just one sample, one person and a very big group. But here they are almost the same groups. Is everyone clear? Okay. Now what I want you to quickly turn to your partner, whoever is sitting next to you. If you have a paper and a pencil, yeah, it will be great. If you can draw and give me your own examples of single, paired, and independent. I'll give you 3 minutes to do that, and I'd like you to share your picture. You can draw in your iPad. I'd love to see drawn in your paper and pencil. And I do not want too many. I just want few. I just want few means work with your partner. Work with the person who is sitting next to you. Please draw example pictorial. I do not want you to write something. Draw pictures with certain dependent variables, and what are you going to compare and how? 2 people, 1 example. So I'm going to get 1, 2, 3, 4, 5. Okay, if you're sitting closer, you can be 3 of you can work together. Troy, you okay to work with her? Yes, you can move a bit. Eric, you can come close to Emily and Arlene. Ashlyn, you can turn to the last person who just come in. You can work with 2 or 3 also, group 2 or 3. Send your answers on WeChat. I'm going to open your answers here. Is that Anna? No? Claire? Claire? Anna! Hat and mask. No problem, Anna. That's why I just put you late. So Eric and Claire are missing. Ashlyn, you can move to Anna. Anna, maybe you can move to, what's his name? Colin. You can work with Colin, maybe? You've got 3 to 4 minutes to think of an example of a single sample t-test, independent t-test, and dependent t-test. I always say the word independent means 2 groups, and dependent is time 1 and time 2. Please share your answers on WeChat. Okay. Do I have answers here? I'm waiting to see your answers. Oh, by the way, hypothesis homework we will do on the practice day. So make sure you do that homework. Remember, I've given you one homework. We will discuss that on the practice day before quiz. Right? So make sure you do this. Now, I'm waiting for your answers on WeChat. You can draw, you can write, whatever way. Eric, you're okay to work by yourself? You're working, you can move there. Talk. When you discuss and you do your talking, it really helps you understand what you're doing. 3 people can work together, doesn't matter. Yes, great, Troy. The more you discuss, the more clear you will be. Okay. Can I see your answers? A little bit faster, please. When you plan your research, and if you know what analyses are available, you can plan your research nicely. Oh, I'd like to compare the 2 groups. What would I do? I can use t-test. All right. I've got one response from Susan and Haley. Stress level, single sample, that's awesome. Dependent variable, dependent is stress and happiness. Okay. For one semester and next semester, okay. All right, we've got one example. Any other people? I'll wait for at least 3 responses to begin discussion. Lynn and Lawrence, yes. Please share. I need at least 3 responses before I begin discussing your answers. Great, Lynn. Lynn, single sample, t-test. Oh, Lynn, you just shared one. Yeah. Square dancing of Benjo with Georgian. How about independent samples? Working? Yeah. Okay, little bit faster, quick. We don't have a lot of time. Okay, Marlena. Awesome, Marlena. Sleeping time of sophomores. We're going to compare with sleeping time of WKU. Or maybe I can open it here. Okay, give me a moment. All right. Okay, guys. Thank you for all of those who have contributed here within the time limit because we have to finish. Look at these examples. Excellent examples. This is a single t-test, right? Single sample t-test, sleep time of sophomore. We're going to compare with the sleep time of WKU students. Look at this. These are the same group. Time 1, physical exercise, and time 2, no physical exercise. What is your dependent variable? Weight, happiness. What are you measuring? Sleep time. Okay. Sleep time? Okay, great. I didn't realize that. So the dependent variable here, just pay attention and you will be more clear and you can evaluate your own examples if they are good or not. So I got it now. Sleep time is the dependent variable, but here a small group is compared to a larger population. In this example, the same group of sophomores, time 1, while they are exercising, how long do they sleep or how long do they take to go to sleep? And 1 month without exercise, the mean of sleep score of 2 months will be compared. But here, there are 2 groups. One is male and one is female. It's not time 1 and time 2. Now, if Marlena and group, put your hands up there. Okay, these girls, if they have designed this research, they have this data. Actually, they have the data from here. Physical exercise, even boys and girls, isn't it? Yeah? Here also boys and girls. They can run 2 independent t-tests. Physical exercise for boys and girls. Is there any mean difference in their time, in the sleep time? You getting it? And no exercise. Without exercise, is there any difference between male and female? Now, Marlena and group, when you decided to compare these means, what's your condition here? Just gender, right? But if let's say this is one study, for example, these are also sophomore students, for example. Yeah, they are sophomores. So which one do you mean here, male and female? Physical exercise condition or no physical exercise condition? Could be any, right? So when you collect data, you can analyze your data in different ways to understand the pattern among your sample, right? It's a wonderful example. Lynn and Lawrence have shared one example, which is also good, but there's just one example. Haley and Susan, your example is good, except Haley and Susan, keep that in mind. You are checking their stress and happiness. For t-test, your dependent variable has to be the same because you are comparing, right? For example, in that condition, they are comparing sleep with exercise, without exercise. So this is a good example. You can have you can compare stress of psychology of PSY 3200, WO1 and WO2. You can compare their happiness also. So you have 2 dependent variables. Just make sure the DV remains the same. All right, everybody? Looks so good, right? Now, if you have the data, it is super easy for you to feed the data and analyze your results. You can analyze your results in 5 seconds if you have the data. Okay? Now, can someone take this picture and always keep it, Merlina and group? We can work on this. We can work on this data all the time. So keep this picture with you. Okay, now let's talk about the bad part. Do you do Instagram? Let's skip to the good part. Yeah, you know that trend? Let's skip to the bad part. Okay, now let's come to the bad part. I'd also like you to imagine what the data would look like. Okay, we will do that later, perhaps, what the data would look like, because you are going to conduct a real research. You're going to collect data and feed data into SPSS. We will come back to this. I think we will take Merle group's example. Let me go to the bad part. The bad part is, do you all remember this? Do you all remember all these signs? Lauren said yes. That's it, one person. How about others? Can I hear a loud yes or no? Do you remember these signs? 1, 2, 3. Do you remember these signs?
Yes.
Very few yes. Not all. Exactly. So the intensity of your yes helps me that some of you do not. Take your time and go through these. And it's Lawrence, you said you remember. Lawrence, what is this?
Me of the sample.
Excellent. And what's the next one?
Next one below or right.
This one?
Me of the
Population. Lawrence is a sophomore or senior? You're a sophomore? Senior? Junior. See, junior brain is more intelligent. Okay. Mean, sample mean, population mean. Okay, other than Lawrence? Sample standard deviation and then population standard deviation. Louisa, thank you. Somebody else? Sample, don't forget about variance means variable, different. Sample variance, this is population variance. These two, even I don't know because you have not done it. Okay, I'd also like you to scribble on your paper the formula for variance, standard deviation, z-score, and z-statistics. You do that, I'm going to do that. You know what? I also don't remember the formulas. I'd like you to scribble these formulas before I tell you the formula of t-test. I'd like you to scribble these formulas. What are the formulas I'm talking about? Variance, standard deviation, you want to copy, you can copy. There is no problem. You can copy. I want you to revise by yourself. The formula for variance, standard deviation, z-score, z-statistics. And when you're done, you're going to speak it aloud, and I'm going to write it down here. Are you ready? Not yet? I just want a formula for variance, standard deviation, z-score, and Z statistics. Are you ready? Yeah? You still thinking? You can think. Yeah, Louisa and Gwen are having a good discussion. These all formulas are like cousins and brothers and sisters, isn't it? Score minus mean, either divide by n or divide by standard deviation or divide by standard error, right? So they're all like relatives to each other. So did you guys do that? Yes? Yes. Can one person take a picture and put in the group? One person. Susan is doing that. That's wonderful. Oh, awesome, Susan. Thank you. Wonderful. Wonderful. Awesome. Great. Okay, guys. So Susan has done that. So I believe all of you have done that. It's not a big deal. I wanted you to open your notes and fire your neurons about, I could have just displayed the formula, but I wanted you to go by yourself, right? Go and look by yourself. Here, I've done a little bit of work. Oh, no, Lulu and Ashley helped me, and then I also improved on the slides. So, we all see this formula? Yeah? The most common thing is we are comparing mean, right? Sample mean, population mean. Sample mean, population mean. Sample mean, population mean. Yes, everybody? Very common, right? Z-score, sample mean, population mean. There is one thing that's a little bit different. What's that? The denominator. Denominator is the one that you use to divide. Yes? Divide. Divide, right? Division. Denominator. Divide. Denominator. So you will remember numerator and denominator. Only the denominator is different. If you take out variance of population, we used population. But for sample, we did n minus 1. Does everyone agree? Then almost the same. But what happened here for standard deviation, it's just the square root. Now in Z-score, we learned that denominator has to be standard deviation. Yes? And then when we moved to hypothesis testing for Z statistics, one thing changed. What was that? We used standard error of the mean. Is everyone okay? If you remember all of this, statistics will be very easy for you. This is like lineage. Child, then father, then grandfather, then great-grandfather. If you remember, things will be very easy for you, right? Now, until here, things were going good. Things got a little bit complicated when you had to divide that by standard error of mean. Now, can anyone tell me what is standard error of mean? How do we calculate it? This one. How do we calculate this? Lawrence had this idea. Yes, Lawrence, I'm ready to write when you say.
Standard deviation.
Yes.
Divide square roots of population.
Population or n. I told you like some books use capital N and some use small n. Everybody good here? So far with me? Perfect. So Our life became little bit difficult when we had to divide sample mean, population mean with the standard error. But the life wasn't that difficult. Why? Because you always had this data. You were given standard deviation and you were given number of people. So very easy, Professor. Why is it difficult? So for example, let's look here. This is what Lawrence just gave me this answer, right? So I wrote it here. Now, sorry. Okay, I'll just go by the slides. Now, for today's class, I keep telling you guys it's so difficult, right? But again, it's not difficult. Is the great grandfather, father, son, grandson, right? Just like you are a little different from your grandfather, great grandfather, right? You are becoming more high tech. You are becoming more complex. Your great grandfather was the simplest person ever, right? Then your father became little bit complex. You became a little bit complex. Now these are your children. More difficult, little bit difficult. Now what is different? What difference can you see here? This is the T statistics. Remember, paired t-test, independent t-test. Here you were looking at the Z table, Z. Remember? Here you're going to look at T table. So don't worry about that. I want you to tell me what is different in the formula. How is your child different from you? The denominator is different again. And what is this denominator like? Look at this one. It looks like this. That's you, and that's your child. But your great-grandfather was so simple, just N. Your father was standard deviation. What do you see? How do you think this is different?
Is the last one a sum of something?
Right? Sum of something? Again?
Simple population.
Sample and population, you are very close. Okay, I don't expect you to know this. I just want you to feel the only difference from Z statistics and T statistic is there is no standard deviation. So what is this? Now, this is something you're going to always hear in your life in statistics, and you will be a little bit confused in the beginning, but trust me, after some time you will be okay. Okay? This is called estimated standard error. Estimated. This was the real actually. You did not estimate. Because you had standard deviation, you had number of samples, so you will take the real statistics out. For t-test, we use estimated standard error. You just estimate. You will say, Professor, why do we estimate and how do we estimate? So the answer is simple. When you have your t-test, you do not have the standard deviation of the population. Here, you always got the standard deviation of population when you were doing hypothesis testing. You don't have the standard deviation of the population, so what do? You estimate it. Now, when I say estimate it, how do you estimate? From the air? I think I'll make 10 or 12. Yes? Do we estimate like that? No. You are going to estimate, because we need actually this, but we don't have standard deviation. You're going to estimate standard error from your sample's distribution, from your sample standard deviation. Simple. Am I confusing you? Am I confusing you? Okay, Troy, your eyes told me something, so let me stop and go back. Okay. Remember, this is your hypothesis testing. I've given you the homework. If you open that homework, you can find population mean in your hypothesis testing? You can find population standard deviation, right? You can find sample mean, you can find number of samples and cutoff values. For t-statistics, everything is the same except you don't have this. Is that okay, everybody? Eric, you look a little bit confused. Eric, these are the statistics that are available to you when you do Z statistics. If you will open up the exams that I have given you, right? You will see all of these statistics are available, except, oh, for t-test, you will have everything but population standard deviation. So what do? Don't forget, you estimate. How do you estimate? The estimate will come from calculating variance of the population. Oh yeah, oh my God, yeah, I've got students coming. I've got some people coming to recruit you. Hold on. Hi girls. Do you think you're a little bit early? Yeah? Yeah. I'll give you 5 minutes. Yeah. You want to come inside and study statistics? Come. Can you welcome these beautiful ladies? Hey, why are you so shy? You should do this. Okay. Jupiter, Erin, you have to say like stop. Sorry, stop. Okay. So what are we going to do? We're going to estimate. How do we estimate? Because we don't have this. We estimate this using the sample variance. All you are going to have now in this example, like all of you, my student A, B, C, D, E, your happiness score on the scale of 10, 7, 8, 9, 9, 10, you are going to have mu of WKU happiness. WKU happiness is 8. That's all the data that you're going to have. And you have to calculate if there is a significant difference between the happiness of my class and the happiness of WKU. Remember, single sample t-test. What is single sample t-test? My class, PSY, 3200 happiness. Yes. And happiness of entire WKU, single sample t-test. Yes, everybody? Remember? When you calculate, you've got this is my population, the happiness is 8, and the mean, your mean, I do not know, I have to calculate it here. I can also calculate standard deviation, right? And I have to compare if this mean is statistically different from this mean. If you are in grade 6, you would say, why do we have to use t-test? Why can't we just minus? We calculate the mean. Let's say the mean is 8 or 8.5. Why can't we just see the difference, right? 8 and 8.5 mean difference. No, we are going to do hypothesis testing. Remember, if the difference falls into the critical region or not. So we cannot be like grade 6 students, just subtract the mean. No, we have to do it statistically. We have to check if it is statistically significant or not. So this is the data that you have. In hypothesis testing, Eric, you would be given the standard deviation of the population. But for t-test, you do not have the standard deviation of the population. Not a big problem. We are going to estimate it. Now, why do they estimate? The statistical explanation is these people are part of these people, isn't it? You guys are part of WKU. If I see what's the variance between you, how different you are in terms of your happiness, I can assume that rest of these students are different in the same way. That's the explanation, right? So I am going to calculate the variance of these people, right? And I'm going to use that variance to calculate right? Then I've got everything. I've got mean, and I've got the standard error of it means. Is it a good story? Do you understand? Yes? So, if ever, Troy, you know you are thinking, don't worry, you may not be able to digest. You clear? You clear? Yeah. Even if you're a little bit confused, don't panic. I will post the slides. You can go through. The story is simple, right? The story, you just try and go and make your connection from this, right? Everything is the same. Here we have standard deviation. Because we here, Z-score, you were talking about one student and the class. But we wanted to talk about sample and population, larger group. So it's important that we consider standard error of the mean. We calculated standard error using standard deviation and participants. But in t-test, you don't have the standard deviation. So what do? This is called estimated error of means, right? How do we calculate that? We will calculate that by using the standard deviation of our samples. Is everyone clear? Yes? Jupiter is trying to revise. Eric, you have any question? No? Jupiter, you revised? T-test. Okay. Now, basically, we did not even start yet, but I've told you the story, so the slides will be very easy. I can just take 10 minutes, and these people will talk. What is t-test? You already know. T-test is the mean difference on the independent parametric dependent variable. Haley and Susan, dependent variable means the two variables have to be the same. Yes? This is why I encourage you to make your own examples, to talk to yourself while you are drawing, participate in whatever your teacher says in the class, because it helps you understand yourself and your thoughts, right? So thank you for contributing, Haley and Susan. You clarified. Merlin's and group is fine. I just saw one example. I hope rest of you, I did not check your examples, but you were able to design your own study. How is it different from similar to Z-score and Z-statistics? You know now. We've already achieved that. Z-score is standard error, but here it is estimated standard error, right? Where is that estimation coming from? It's coming from your sample variance. Perfect. And work from formula by hand, just for knowledge. Do not freak out. I have put that on the slides, not for quiz. So don't freak out. But I do not want you to finish my class and meet another professor and say, I know t-test, go to analyze, t-test, pair t-test, click, and I'm done. I want you to understand these statistics. I want you to understand what's the story behind it. Okay? So when I say only for knowledge, do not freak out. But tomorrow, I hope we will continue calculating using SPSS, effect size, confidence interval. This will be rest. So let's go to the difficult part. Let's skip to the difficult part. Skip to the good part. No. Okay, I've done this. I just told you about this. I'm not going to read. How do we do hypothesis testing with Z statistics? You know that. Remember the table I showed you? For Z statistics, we use Z table. But for T statistics, we use T table. Anna is a math major. Anna, you know all the tables, right? Math people, do you do all the tables? You know better than all of them, little bit, right? For this, we are going to be using, do you remember for Z statistics? We've not done the quiz on hypothesis testing yet. So you might not be you did not memorize the things that you memorized, right? For hypothesis testing, at 0.05 alpha, you look for the value 1.65. At 0.01, you look for the value 2.33. Remember, everybody, the curve? But for t-statistics, you're not going to use the same statistics. You're going to use t-table statistics, which is very similar. Okay? Is everyone with me? Yes? This is an example of the Z statistics, right? I just put it here. But we are going to use t-table. This is how the table is going to look like. Just like Z statistic table, this table is available at the end of most statistics and research methods book. You can also search it on internet. I'm sure you have a Chinese version of this. Now, how do we see that? This is your 0.25 probability, 0.01, 95% probability, 99% probability. You've got so many options. There's just one thing different is degree of freedom. If I go back here, how did we used to do that? We used to do that top 6%. You will look in the table. Remember what is top 6%? Here, remember we did that? Top 5% will fall here, right? For this shaded area, what's the Z statistics? When you look at the top 5%, you say the Z statistics for this is 1.64. Do you remember? If I want top 1%, the Z statistic was somewhere around 2 point something. So we were looking at the tail and the body and the Z statistics. Sometimes for Z score, I gave you the Z score. Remember? The Z score is 2.60. Find out the raw score. Yeah? So what did you do? You went to 2.60 and you found out it falls into how much top, and then you calculated your raw score. For t-statistics, you're going to focus on degree of freedom. Now, I do not want you to feel what's degree of freedom. I'm going to explain to you that in the next class most probably. Okay, but just say degree of freedom 2 and 0.05 probability. This will be your t-statistics. It's just an introduction. We will use that very soon. Is everybody good until now? Sure? Any questions? Okay, don't worry. You will take some time to digest. Please give at least 20 minutes in your dorm to revise. So if you have questions, you can ask me. All right. Now, just before you collected the data, and Professor, my research is ready, and I'm going to analyze my data using t-test. Okay, I will say, very good, go ahead. But before you analyze, you have to make sure there are certain assumptions. Assumptions means you have to check if your data is good data. Can you run t-test with that data? It is you going to the mall and you want to buy tomatoes because you want to cook some food. You will see if tomatoes are right or not. Can you use them or not, right? Just like that, in real life, we check things. Will it be okay or not? You have to check your data. For tomatoes, you check, are they red enough yet? And you touch them. Oh, if they are too soft, too ripe, you can't use them for your soup because they'll become like mushy. How do you check these? How do you check your data if it is ready for t-test or not? You check. First is, was the data drawn randomly? Was it drawn at random? Because if it was not drawn random, for example here, happiness of PSY 320, I'm comparing with the entire university. If you guys were not randomly chosen, I might be biased and choose only the student who always smiled in class, right? So in t-test, if your data is not randomly chosen, your answer could be biased. Okay? Or maybe I chose only rich people who tend to be happy. Is a misconception. Yes, Erin. You want to ask something? Oh, it's time? Okay. 2 minutes. I just finished this. We assume that observation is not related to any other observation, means these data belong to happiness, means it belongs to your psychological well-being, not happiness looking at pizza. So observation have to be very independent. Another one is observation are sampled from a normal distribution. Again, if you are randomly chosen, I believe some of you are very happy, some of you are not so happy, some of you are, so it should be from normal distribution. I should not get data from all very happy students, right? Otherwise, my experiment will not work. Homogeneity of variance. Now, what's that? We assume that the variance of the sample is same as the variance of the population. Remember? If I've got 2 unhappy people in my class, I expect at least 20 or 200 unhappy people in my population also. Isn't it? The variance, how the data is spread over, should be similar in my class and in that class. Is that okay? So these are important things for you to remember. We just did the single sample t-test is very identical to Z statistics. Only one thing that is different is in this, standard deviation of population is not known. Yes, you all remember that? So again, the same thing. We knew this. This was easy. Father, grandfather. No, that's your father. That's you, and that's your child because great grandfather was variant, right? So this is estimated standard error of mean. I wanted to revise, but we don't have the time. What do I do? Do I give these girls to you? Okay, fine. I think I'll stop here. Okay, and we will continue how to calculate this. We'll continue for the next class. Don't worry. Right now you have an idea. Okay. Now these girls are going to talk something about their experiment. I will share the slides and we will continue discussing it. Okay. All right. Okay, Erin and Jupiter, most welcome.
So, hello everyone, and my name is Erin, and this is Jupiter. So, first, thank you very much for giving us 5 minutes to do our recruitment for our experiment. So, I want to first have a question to you, and how many of you did not hear any type of ASMR in last 2 weeks?
Wow, is that so common in China? All of you here at ASMR?
Please raise your hand. How many of you did not listen to any kind of ASMR in last 2 weeks? Did not. 没有，最近2周里面没有听过任何形式的 ASMR。Did you either ever heard this before?
Psychology major, ASMR. Yeah, a lot of people are raising their hands.
Okay, so our experiment is for people who raise your hands. Yes.
All right, just a minute, just before. I highly encourage you to participate in this experiment because you can connect your statistics with the design. What 2 groups, how are they compare the data, what statistics, and psych major especially, you're going to take yourself PSY 4230. No, you are in 4960, but you are continuing the 4230 project. See? So I highly encourage you to participate in this experiment. You will get ready for your own PSY 4230. I hope I teach next fall. I like that class. And you will use the same data for your capstone project. And you can connect your statistics knowledge while you go and participate in experiment. So I highly encourage you to do that. I will turn off the recording. You continue recruitment. Thank you, everybody, and see you later.
Okay, just let